Hello everybody, this is AYDENandDAD, and
today we're going to show you how to repair a steam clothes iron.
So, this particular model of steam clothes iron is a Black & Decker Quick and Easy 485.
Yeah, it's a few years old, probably 10 years old at least, and it's worked well until now.
Yeah, so Dad, I just came downstairs and saw you tinkering on a thing, so what was wrong with it?
Mum complained earlier this week that the thing's switching on, like you can see there, but it's not heating up. Okay, before we continue, let's unplug it from the power supply. Why don't you show us what tools we'll need for this job?
Right, first ingredient for fixing something is a soldering gun. Make sure it's 100 watts, some lead-free flux, and of course some solder. 2 regular-sized flathead screwdrivers, and a Phillips head or star screwdriver, and a slightly smaller Phillips head or star screwdriver. An adjustable wrench, and we have needle nose pliers, but any form of pliers will work. There's a T-bar adjustable screwdriver thing, and these 2 screw heads, a number 1 and number 2 Y fan blade peace sign thing. That's just for the first screw, So the other things you will need are a wooden dowel for applying pressure to a part, an X-Acto knife for prying things off, and a voltmeter, multimeter, whatever you want to call it. You don't need such a fancy one, you just need AC voltage and resistance. Another thing you need is a towel, and if you're working on a wooden surface or a surface you care about, plastic under the towel. Now, you need the towel because if you don't drain the clothes iron, as soon as you do something, water will pour out all over your surface. So just a heads up for those that want to know about such things.
Okay guys, so the first problem is to loosen this Y nut here at the back. Now Black & Decker specifically used that type of nut to dissuade you and me from opening this thing. If you don't have this specific driver, you could try a small flat and just put it in one of the sides and see. I think you should be able to undo it like that. But I just bought this 10 years ago at one of these $1 bins at the hardware shop, so it should be available. Never had to use it until now, so let's see how it goes here. This is working in reverse here so you guys can see. I'm gonna do the righty-tighty thing instead of lefty-loosey. So you'll see it comes out easily. And I'm just gonna move it a little bit this way. It's got a few catches at the bottom. You turn it this way, you'll see there's a couple lips there.
You can't really see them, but it's like the back of your television remote when you put in new batteries.
Yeah. Anyway, there's 3 wires there that it's restricting you a bit. Here's where you need the regular Phillips. Let's undo these 2 Phillips head screws. And in many of these irons that stop working, the problem is actually on the cable here. Because the cable moves here, the manufacturers do a great deal to try and mitigate the bending of the cable, but in many videos you'll see people have cables that break there. That's not the case here. I've tried that. This cable is fine. So this thing just comes off like this. Now we need to remember to reroute this cable back that way when we put it together. That's kind of important. Okay, so that's the power cable coming in, and you'll see it goes into the one end of it at least. Goes into this little electronic board here. I'm just going to put this off to the side. We don't need that now. And again, you'll see Black & Decker put some epoxy on all these components in the bottom there. So you can't really take one out without breaking that off.
For those not knowing what epoxy is, it's basically clear plastic. They basically plastic wrapped their components.
Yeah, and this circuit is a temperature sensor. You might have noticed here on the front it says auto off. So if you know this iron, you might have noticed if you switch it on, you leave it on for a while, after a bit it auto switches off when it reaches a certain temperature. So I guess that's what the circuit is doing. You can see it's got the solenoid there on the switch, and I'm sure all that is a heat sensor and whatnot. So the first thing would be to test this to see if we get power in. Now you just follow these two black cables. The one terminal is here and the other one is right there. So that's the first thing we'll do. Let's plug it back in. Okay, so the first thing you do is put your multimeter on AC voltage. That's that little tilde sign, because this is 110 or 120 volts in America. In your country it might be 220, 230, 240. And let's measure what's coming in, if there's continuity up to this point. So we're gonna go on this point with a one probe and see that one back there. And be very careful here. This is 126 is what it says there, Aiden?
Yep.
So that's good. The next thing we want to check is if this circuit, if there's something wrong with the circuit. So is the power that we get out, which comes out of here, you can see it goes in here and it comes out here. So if we still get 110, 120 between these 2 points, let's turn it on. So I just push this little switch here and you'll see the lamp, and this guy actually is now working, so I don't want to burn myself. So I did put the control knob on 0, you know, where you set the steam and the heat. So it should be off. So this is the output. So after this little board with the power switch on, I still measure 126 volts. So it tells me that circuit is good. Whatever it does is good. So our problem's not there. So I'm going to switch it off and unplug the power, and we're gonna continue this assembly. Okay guys, so we unplugged it. Here's the plug. Always make sure you do that before touching these contacts. So first thing is we want to pull this connector out, and also this one here. Okay, let's take this out of the deal here.
So the iron should now be completely separated from the cable. So let's just zoom out and get a shot of that.
Right, and just to show you, I always had it here on 0, which
can't see it either.
Which is off position there, just to make sure it doesn't heat up while I'm working on it. Now the problem is, what do you do next to disassemble this thing? There's no obvious screws here that we can see, and I did notice these 2 tabs here. Can you see that? That's what we need the flat screwdrivers for, but that doesn't release this whole top bit. So the only other thing I could think of was here. So let's try to pry this off. So just using a flat screwdriver, wedging it on the edge here.
If you're squeamish about something flying off, maybe apply eye protection.
Yeah, it's always best to use safety glasses. So you'll see there's a little slit there in this knob there, and that lines up with this little pin here. I then noticed that this thing is loose, this little decal here, which is what we're going to use this X-Acto knife for. So we'll just slip it under one of the ends here. Pop one end out and then it comes out. And you'll see if I turn this knob back counterclockwise, there's another screw there. So let's unscrew that. Okay, it's loose. And there goes the top. Okay, there's this thing that just basically falls off. We'll just remember it slips in that little notch there. And it's got a little indent there, which clearly goes on this adjuster here. This is your variable control knob, like that. And don't lose the bent spring washer on top. Next, you'll have to remove these two knobs here. The one is for the steam and the one is for the sprayer. Okay, this is very easy to just pop off with your fingers. It's got these two little hook thingies in the back, and in the front it also hooks, but it's got a, if you twist it a little, it'll unhook there. Okay, let's pull it a little bit and twist it, and there it comes out. You'll see two other things dropped out of that. One is a little ball bearing, and one is a spring. And if you can see there, in that hole there, you'll see there's a small little hole there off to the side a little bit, and that's where the ball bearing goes. So the spring and ball bearing forms a little one-way valve in that tube there. The other thing of note is you'll see that these are plunger type thingies. So obviously when you push down on them, they push air into the reservoir here where the water is, put pressure there. Some water comes back out past this one-way valve, which gets held down by the spring, and then it sprays out either in front or down into this compartment in the front where it creates more steam. So I'm gonna just disconnect the other one in the same way. You'll see I'll just unhook it there and then turn it slightly, and this one brings the spring out. There's actually little catches here as well around this front end that catches the spring a little bit. And I intentionally haven't cleaned it so you can see what a used one looks like. Obviously before we put all this together we'll clean it as well. And there's one more ball bearing to come. There it is.
If you're worried about losing it, just get a plastic baggie or something.
Yeah.
For our purposes.
You want to keep track of this. If you lose one, but you're never going to put it together again. Yeah, I'm just using this and throwing everything in there.
You'll recognize that as the power button.
So the back lid keeps all the little parts. And there's one more bit that you want to take out now, and that's this thing. And this is really the valve for that creates the normal steam. The water that's in the reservoir here, depending on where your control knob is set. So if you move it to the left or anti-clockwise, it's on the dry cycle, and if you move it more to the right, it's towards the steam. So that is where this guy comes in with this other part that I showed you before, which it rides on there, and this here is pulls it up on that side. You'll see it wedges around this point, and when it pulls this end up, it pushes the opposite end down, which pushes this rod down, so it locks the dripper. The water drips from the reservoir onto the element there. So that's how they control whether it steams or not. It's through this simple little device, which works excellent. So before we go on to the next step, what's important here is to disconnect this pipe, because it connects top to the bottom. And you'll just find if you lift this up that's gonna get in your way. So disconnect it now. I just use needle nose pliers to pull on it. Be careful that you don't want to break it, and maybe you can help it a little bit by pushing it with a screwdriver from this end there. And if you can get your bare fingers in there, grab it and pull it off. And you'll also note down there's another screw, and that's what we need the smaller Phillips for. Okay, I'm just going to put it flat so I can work on it. unscrews easily. To get this whole thing off, you'll see it wants to go off here because the screw is loose, but then these tabs are still holding it in place. So you might have to use these other two flat screwdrivers. Push one in this side, one on that side. We just want to get it past those tabs there. And there it goes. So let me show you those. You'll see they do have little lips at the back, so you can push them, but they go at an angle. So obviously these here are parallel, so you need to get them past these hooks here on either side there. Okay guys, a few things fell out when we turned this over. One is this little grubby looking piece of rubber, and this as you can see goes there. You'll see the reservoir's bottom outlet, which remember was controlled by this little thing. Hope you can see it on the black there, which goes down there and closes that hole or not, depending on whether you want steam or not from the top, right? So this just keeps everything, all the water contained. I don't know how it withstands the heat though. It must be a very special rubber. So obviously I'll clean that up before putting it back. The other thing that came out was this. Let me turn this around. You'll start seeing the control knob down there. It's flattened on the one side, on the bottom there, on this edge there. And you'll see this guy, it's got a little springy thing there, and it's also got a flattened end there. So obviously it goes like that. Let me show you from a few different angles. And it just sits slightly tight there, but not too tight, and obviously you can turn it all the way to the right, all the way to the left. This is the off position, and that's the steam position. One more screw here. Here's the little tube that we undid on the top, and I don't know if you're aware of this, but this end here, this is always almost exactly the size, so that you can just use it as a tool like that. And if you have one of these screwdrivers with the bits on the end and a pipey thing in the middle, that one of that sizes is exactly this one as well, in case you didn't know that.
So at this point we're still trying to find the problem, right?
Actually at this point we can measure again. That's a good point. Let me just unscrew this first. I think it's loose there. Okay guys, so for this bit we're just gonna switch to the ohm reading on the multimeter.
That's the omega symbol.
That's to measure resistance. And inside here is an element, and that's what's heating up when current flows through it. Let's just see what that measures. And that's what I saw when I measured this. Now currently I simulate this by switching it off. I've turned this control knob all the way to the left, so it's got some points there under here, which I'll show you now, which is disengaged, so it breaks the circuit. So by just turning it a little bit to the right, it engages. So that should give us some reading. Let's see. Yeah, you see 12, 13, 14, roughly something there, ohms. And it's just varying because I'm not holding it steady, I guess. That 14 ohms is what you should be seeing. I've actually looked this up. I was amazed that it's such a small reading. I expected higher resistance, but it's not. That's typical. Obviously I didn't get any reading, so if you don't get a reading through that with the control knob being turned to the right, there's a problem somewhere down there. Now that's sort of, again, the last thing you want to do. Although there was the screw here, you'll see they dissuade you from going in here by putting these tabs on here, which it's like twisties. They just twisted them a little. So let's reverse that. So just bring them in line.
Using our wrench or
yep. Yeah, or any sort of pliers would work.
If you have strong fingers, very strong fingers, that might work.
Yeah, I don't think you're gonna twist it with your fingers. It's a little tougher than that.
You never know.
So you can see already it now wants to come off. So that's fine. The one other thing you want to twist is this connector up here, which this one is solid, you know, but this one is very movable. And I thought when I felt this the first time, I thought something is clearly off there. That's why it's so loose. But you'll see why now. So just bring it in line with the slot. And let's see if we can just get it to slide up. This guy needs to go out. And there's the top off.